All right, this is I think the last time that we're going to be looking at solving radical equations. It's the same thing, it's just a little bit more to do. The first step here is to get a radical isolated as best you can. So nothing in front, nothing behind, on one side of the equation. So that's what we have already. It's already isolated. So then the next thing is to try and get rid of the radical. So I would square both sides because that would get rid of that radical. However, this, if you remember, it's x plus 1 times x plus 1. That's what a squaring a binomial means. And then we have 7x plus 15. We just have that regular. And then what we do is we FOIL this out. That would be x squared plus 1x plus 1x plus 1 equals 7x plus 15. So I'm going to combine like terms, and I have a quadratic, so I'm going to get everything to one side, see if I can factor. So I got x squared plus 2x plus 1 equals 7x plus 15. I will subtract the 7x over and subtract the 15 over to both sides. So then I get x squared, that's minus 7x there, so minus 5x, right? 7, 6, 5, yep. And then minus 15, that's minus 14 equals 0. And let's see, now it's a quadratic that should look familiar. And I'm going to try and factor. Remember, it's this number times this number. 1 times negative 14, that would be negative 14. And then negative 5. That's just 7 times 2 is 14. However, the 7 must be negative. There's a 1 in front of there, so I can use my shortcut. We're just going so fast. X minus 7 times x plus 2 equals 0. And then I can set each piece equal to 0. So x minus 7 equals 0. That means I get a positive 7. And then x plus 2 equals 0. Subtract 2. I get a negative 2. So I have two answers. But just like before, I need to check them. We have to check them because whenever we're squaring stuff, we don't know if we're getting rid of negatives or not, especially because we have a variable on the other side. So let's check. This is something that's very important. Check. Some people got it wrong in the quiz. First, I'm going to check x equals 7. So I plug in a 7 there. So maybe I'll rewrite the original. There. So I'll plug in the 7, and I get 7 plus 1. Easy, that's 8. Oh, very good, very good. 7 times 7, right? I'm plugging in a 7 for that. Is 49. 49 plus 15, that's 59. 64. Ooh, that works. It's a positive, right? Because there's no negative in front of that. So 8 equals 8. That works. 7 is one of our answers. Great. Now I will try negative 2. And I'll plug in the negative 2 to this. Ah, here we go. Immediately you could tell. You don't even have to do the rest. Negative 2 plus 1. That's negative 1. Well, I can't have a square root, a positive square root even, because it's positive there. I can't have it equal a negative number. There's no such thing. But if I plugged in negative 2 there, that would give me 14, right? Or sorry, negative 14, which means negative 14 plus 15 is positive 1. Square root of 1 is 1, and that is not true. So this one is extraneous. So the only answer is x equals 7. I'm going to do more examples, of course, but let's review the steps real quick. First, we tried to get the radicals isolated on each side. We tried to have nothing in front of the radical, nothing behind the radical. I mean, that was already like that. And then you square both sides and solve like normal. Factor and do whatever you can. Okay, goodbye.